Alright, so let's solve an interesting trig equation. So feel free to pause the video if you're very confident you're able to solve trigonometric equations and then compare with the answer I'm going to have here. Alright, so we've got double angles here, right? 2x, 2x. In what way can we handle them? Now because of that square, I would want to avoid substituting indirectly and I want to go by substitution. So letter y or any letter of your choice be equal to any of the double angle. Let me go for cosine. Since that is squared, that would be y is equal to cosine of 2x. Now there is a very familiar formula. Sine squared of any angle theta plus cosine squared of any angle theta should be equivalent to a 1. And so if you make any of the two to be a subject here, let's say you make sine or cosine, you are going to notice something interesting here. Let's make sine. Sine squared of theta is equal to 1 minus cosine squared of what? Theta, right? Now, even if we put a double angle formula there, let's say sine squared of 2 theta, in this case, of course, 2x, that's still equal to 1 minus cosine squared of what? Of 2x. Okay? So this is going to be a very essential formula to help us deal with what we are working with, right? And so don't forget that we've got this part in that equation, right? 2 sine squared of 2x. So we want everything to be in the form of y. This part, which is cosine squared of 2x, can be written as cosine 2x to the power 2, so that we can just have 1 minus y squared, right? So coming from a very simple formula that we've come up with, so we've got this part, which is the first part, being 1 minus y squared. And so if we substitute, we're going to have 2, and then we have 1 minus y squared plus 11. Now cosine of 2x, we've said that y, right, plus 4 is equal to 0. Now you can see that this has now led to a very simple and basic um, quadratic equation. So if you're a person who is wondering on how we can expand double angle formulas like sine of 2x, which is another alternative, but in this question it will take us a longer way, you can actually check out our video on double angle formulas on either our website or on our YouTube channel, Double Angle Formula Transcended Institute. You'll be able to see that video. So this, for example, is basically equal to 2 sine of x cosine of x. So you can now see that the double angle has actually gone when you expand. Okay, now let's get back to business. So here let's distribute the 2. So I have 2 minus 2y squared plus 11y plus 4 is equal to 0. Writing it in the order of starting with the highest power, I've got negative 2y squared plus 11y. 4 plus 2 gives us a 6. Those are the only two like terms we have. Can we factorize this? Product, negative 2 by 6 is minus 12. The sum is 11. Think of any two numbers we can multiply to give us negative 12. And then when you add them, they give you 11. I can think of 12 and a negative 1. These are the two factors we can think of. And then we put negative 2y squared plus 12y. So you can actually practically use any formula of your choice to solve quadratic equations. I'll opt to go for this one. Look at the first two. Factor out 2y. And so since we prefer starting with a positive, okay, anything is fine. 2y, we're going to remain with negative y. The other part is going to be 6. Okay, if we put a negative 1 there, we just have to maintain it so that it matches up to what. So we just use the 1 so that we remain with negative y plus 6 as it is. This is equal to 0. Don't forget what our goal is. Our goal is to find the values of y, right? So 2y plus 1 will form one bracket, and then negative y plus 6 will also form another bracket, right? And this is all equal to 0. So 2y plus 1, which is the first part, is equal to 0. Negative y plus 6, the other part. 2y is equal to negative 1. Y is equal to negative 1 over 2. Negative y is equal to negative 6. And y is equal to 6. So these are the two possible values of y. Now, for us to answer the question, we have to get back to what we said. Let our y be equal to cosine of 2x. So cosine of 2x should be equal to the two possible answers. If I try 6, so how does that look like? So that would require you to find the cosine inverse of the other side. Cosine inverse of 6. Okay, so practically you can actually see that that's not doable, so this does not exist. The other route, or the other possible answer, would be 2x is equal to cosine inverse of negative 1 over 2, which we are able to handle, right? So we're able to handle that one. Okay, so let's try to work on that. Let's try to simplify it. So let's try to ignore the negative. So we've gotten to a part now that requires you to have an understanding of how you can solve simple trigonometric equations. So ignore the negative. Try to think of an angle. What angle of theta can give you, what cosine of an angle can give you half, ignoring the negative? So that's theta is equal to 60. If it was sine, it's going to be 30. Now for cosine, it's 60. Now we're not interested in the 60 because 60 gives us a positive answer. We're interested in the angles that can give us a negative. So where is cosine negative? All students take calculus. I just hope the noise in the background is not affecting you. Sorry for that. So where is cosine negative? It's positive there. Everything is positive in the first quadrant. Now in the second and in the third, how do we find angles in the second quadrant? So for the second quadrant, you want to subtract from 180. So that gives us 120 as the first possible answer. And then in this quadrant, you add to 180. So 180 plus 60. That should be a 240, right? So 240 degrees. And then if you divide by 2, the two answers you're going to have is x is equal to either 60 or 240. That's going to be 120 degrees. So these are the two answers in degrees. Now, of course, what we have, the requirement in our question was to find answers that are between negative pi and pi. We can easily convert to radians, right? We use this conversion factor multiplied by pi over 180. So 60 pi over 180 for the first one. The other one 120 pi over 180. So just find the common factor. This one we can easily divide. That's a 1, that's a 3. So pi over 3 for the first part. Here 0, 0, there divide by 6, that's a 2. Here divide by 6, that's a 3. So 2 pi over 3. So these are the two possible answers. These two answers are between 0 and 2 pi over 3. Now if you want to find the possible negative results, try to picture the quadrants like this. So the two answers we found are A. So this is 0, and then we've gone as far as pi there. Now if we're going to find negative pi, it implies we go the other way around. Okay? So if we go the other way around, what angles are likely to give us negatives? The same stands. all students take calculus. So the first and the fourth quadrants are still out because cosine is going to be positive in them. So if we go the other route, the only two sides that are going to give us possible positive answers or negative answers is in this quadrant and in this quadrant. And so it will be like this. This is going to be again, now this one is going to be, it's going to be like in the reverse. So instead of being remember this is negative 180, so negative 180, what if you remove the magnitude? So from that you remove our possible answer. Remember what we're using is what we're using is the 60, which was the angle in the first quadrant. So again that would still be, except to be in the negative, to be negative 120, and then it will be afterwards it will be negative 240. And so in short, just the reflection of these other answers, which will now make the possible answers to be negative pi over 3 and negative 2 pi over 3. So I've wasted a lot of your time in explaining that. So just after you find the answers where your x is going to be negative, you can actually reflect them if you're dealing with between negative pi and pi. So these are the four possible answers because of the inclusion of the negative results to our question. So just a quick recap. And now we answered this question. We just said let our y be equal to cosine of 2x, and then we used the identity sine squared of x is equal to 1 minus cosine squared of x because of that squared part there. And then we saw that actually if we put 2x as well, it remains. And so since we've got y being equal to that, which is equal to that, this became sine squared of 2x being equal to 1 minus y squared. And then we got this part, put a y there, and then got this part plugged in where we've got sine squared of 2x. And that's how we came up with a quadratic equation that now helped us to find the value of y. And then we got one value of y, which was negative half, and we had to equate it to the cosine of 2x. And then we just solved this as a basic, simple trigonometric equation, which has given us these four possible answers because of a negative pi to the pi.